Hi guys, this is glaciers, another agent of erosion, and this one is one of the most important ones for our area. It's shaped our area incredibly over the last, few 100,000 years. We've had a series of continental glaciers that have come over top of us. About 12,000 years ago, there was a mile of ice sitting on top of Canada. So if you think about a mile, that much ice from ground up, 5,000 feet of ice sitting on top of us, and it wasn't just sitting there; it was moving. So it was moving over the landscape. And if you look outside and look at the hills, all those hills are rounded and smoothed over because the glaciers were just moving over, and as they did, they just ground away any peaks that were on any of those hills. So a glacier is just a very large, slow-moving piece of ice. They form at high elevations. They form when more snow is falling than is melting in the summertime. Gravity causes glaciers to flow downhill in a valley or spread out over a continent. They start usually at higher elevations because it's usually colder and you get more snow up there. They either at higher elevations or at higher latitudes. So continental ice sheets will start in the north, north of Canada, work their way down, move down, and then when they get to a point where there's more melting than there is snow, then they'll start to work their way back, melt back up north. So they move from the north to the south, and then they melt back up from the south to the north. They can do a number of things. They can pick up materials from the ground. They can just act like a bulldozer and push things in the front. They can carry and drag things underneath the glacier, and they can also destabilize the side of a mountain. So as a glacier is moving in a valley, so if you imagine a valley, glacier is moving through that valley, it can destabilize the walls of that glacier or that valley, and rocks can fall in on top of the glacier. As the glacier is moving, the rocks fall on top of it, and the glacier just moves along. More snow falls on top of that, and that rock kind of gets buried, and it can get carried and pulled into the United States from Canada. So I'll show you one of those examples in class. It's one of my favorite rocks. I love to pull it out, so I'll show you that rock in class. The deposition that happens as the glacier melts back, as that ice melts, it just sort of drops whatever material was in the glacier. So if it picked up big, little, medium-sized pieces, they all get tumbled around inside the glacier, and then they just get dropped all at once. So it's unsorted sediments. It's one of the key features of glaciers is they're unsorted. As well, these things called striations or scratches. So if you imagine sorry, I just had to go get a couple rocks to just show you this. So imagine that there's this big block of ice. It picks up a rock underneath it, and this rock then gets embedded inside the glacier. And as that glacier is moving, my hand's the glacier, as that glacier is moving over the bedrock, over the rock that's underground, on the ground, as that glacier is moving across that, the rock itself, this rock, will make grooves or scratches inside or on top of the bedrock. And when that glacier melts back and we look at the bedrock, we'll see lines and grooves on the surface. And you think, well, this little rock's not going to make a groove. But if you imagine that a glacier picks up a boulder, the size of a car or the size of your house, it picks up that rock and it gets buried under a mile of ice. That mile of ice is pushing down on top of that rock, and it's grinding along the surface, and it can create pretty big scratches in the bedrock. It also acts like sandpaper. You get these little rocks in there, acts like sandpaper as it moves along the surface, and it can smooth out the surface as well. And sometimes they get rounded and smooth. The rocks inside the glacier can be rounded and smooth. There's many features within a glacier, things called moraines. These moraines happen when this glacier is retreating, when it's going back. As it goes back, it drops material in piles. It'll do that because the glacier may stop moving for a bit, and when it stops moving, the the ice is still sort of melting and transporting some rock to the front, and you get a pile of deposited material. And it's unsorted material, unsorted rock, that's all deposited in a line where the glacier ended up. Drumlins are these little hills that are formed inside the glacier. An esker is a channel of rock. You'll get outwash plains where material gets washed out here. There's these kettle lakes where blocks or boulders of ice get buried underneath or inside this moraine or this material that's being deposited. When that block of ice melts, you get a nice round lake. There's great examples of these things all around us, and I'll talk about those in class. I'll show you some pictures of things of these things. One of the things, sorry, did I skip? I did skip this. So they form, one of the things that is classically characteristic of glaciers are U-shaped valleys, and they can, if you look around by us, if you're driving up any of the valleys, as you go up to Ithaca towards Wilseyville, or even south toward Owego, if you look out across the valley, you'll see it's nice and flat, and then you get these nice round sort of hills, and it gives this nice U-shaped valley. Not a V channel that is typical of streams. Transports sediments of any size, so it can pick up pieces of rock that are the size of houses, all the way to little pebbles. The rocks tend to have scratches or striations because they get ground around as the glacier moves. And here's a nice example of one of these U-shaped valleys. This is called a hanging valley, and that's what that picture's for. Some of those other pictures of some of the things that are typical of glaciers. The Finger Lakes, perfect example of what happens with a glacier. The stream valley or lake itself, the stream valley channeled the glacier, and the glacier dug down and widened the valley. And then as the ice retreated, it stopped at one end, the Ithaca end, let's say, and deposited a bunch of material. Moraine filled in that valley. And then the glacier melted back. When it melted back, it exposed that open valley, that U-shaped valley, and then it stopped at the other end, deposited more material, and you create this sort of bowl or basin where that can fill up with water. So the melted water filled up the valleys, and the moraines tended to act like dams on either end of that valley to block the water flowing out either way. So the direction of the lakes shows the glacier moved in those former stream valleys, and if you notice, all the Finger Lakes, they're all running north and south. They all run north and south because the glacier came down from the north and then retreated back up to came south, and then it retreated back up north. The Great Lakes also formed at the end of the Ice Age. Last Ice Age was approximately 10,000 years ago. Filled in that area that was carved out by those glaciers. The meltwater filled in, and they contain about 20% of the Earth's fresh water. Very important resource that we have not taken the best care of. So one of the things that glaciers are hugely important to us. We can see the processes that form the area around us by these glaciers, and we can see where they're doing that today. When glaciers are melting back, we can see these things that we can see around here. So that's all for glaciers. I hope you liked it. If you have any questions, please let me know.